Hey guys, welcome to Literal Equations. We're literally going to be solving equations that contain only variables. And that's what literal equations are. Equations containing only variables. And you've seen them before, okay? The area of a rectangle, length times width. The perimeter of a rectangle, P equals 2 times the width plus 2L, okay? Those are literal equations. And what we're going to do is we're going to rearrange these equations by solving for different variables. So in this case, we've solved for A, we've solved for P, but now what we're going to be doing is picking a different variable and solving the equation. So you have to think these are equations. You're going to follow the same thing that you do in one-step, two-step, multi-step equations, equations with variables on both sides. Just because you have variables doesn't mean you're not going to apply these same rules, okay? So let's look at a couple of examples of solving literal equations. It should say example 1, but we'll go with it. So example 1, we're going to solve P equals 2W plus 2L for W. Okay, this is the perimeter formula. So I rewrite my equation, and I wrote W in red here because that's the variable of interest. Okay, so we're going to solve this as any other equation, and we're going to isolate W, get it alone. Okay, so we see that 2L is on the same side, so we're going to subtract 2L from both sides, and we're going to have P minus 2L, and that's equal to 2W. Okay, you can't add P and 2L together. They're not the same term, so you can't add them. We're left with 2W on the right side, so now all we do is to get W alone is divide each side by 2. So we're left with P minus 2L over 2, and that's equal to W. And that's it. That's solving a literal equation, okay? The only thing we have to be careful of is that obviously when if we have to divide by another variable, the variable is assumed not to be 0 because we can't divide by 0. So common error here, be very, very careful of, a lot of people love to cancel those 2's out. Okay, when you think back to fractions, you cannot cancel just those two 2's out. It doesn't work with that operation right now. Okay, so W would not equal P minus L. So just be very careful of that. Let's look at some more examples. Here's our actual official example 2. Let's solve AX plus C equals BX plus 10 for X. So I rewrite my equation, and now notice I have two X terms, one on each side. So we're looking to solve for X, okay? So get X terms together. So I'm going to subtract BX from both sides. It really doesn't matter because we don't know which value is larger, A or B, so I just chose B. So I subtracted BX from both sides, so I'm left with AX minus BX plus C equals 10. Now notice how AX and BX are in red, okay? They have the same X term, so we can combine them, okay? But notice right now they both have X's in them. I have to solve for X, so I have to get X isolated by itself. So we're going to factor out an X, but that's going to be a second here. So we could factor it out, or we could subtract 2 off, and that's what I did first, or subtract C off. So I subtract C from both sides, and there in red again, AX minus BX equals 10 minus C. So now what I'm going to do is look at that red expression, AX minus BX, and factor out what's common. The common term is X. So I have X times, in parentheses, the quantity A minus B. I factor that out. That's equivalent to 10 minus C. 10 minus C just comes along for the ride. Now I can get X alone. I can isolate X. I just divide each side by A minus B, and that's what I've done. So you have 10 minus C divided by A minus B. That's equal to X. We've solved our equation. We got X by itself. So you just have to be very careful when you have those two terms that they share a common variable, X, okay? You have to factor X out in order to get X alone, isolated. The other thing we have to assume here is that A cannot equal B. If A equaled B, we couldn't do this problem because you'd have 0 in the denominator. Let's look at one more example. Okay, solve, example 3, solve A equals 1/2 times the quantity B1 plus B2 times H. Okay, we're going to solve that for B1. So I rewrite my equation, and I've got a lot of things going on here. So I did it step by step. You can combine steps if you'd like, but first I got rid of this 1/2 by multiplying each side by 2. So that's why in red you have 2a, and there's no 1/2. Okay, I multiplied each side by 2, so I have 2a now is equal to b, the quantity b1 plus b2 times h. So that h is still a problem. I've got to move the h. So I divide each side by h. Okay, again, assuming here h can't be 0. We're talking about area, so h wouldn't be 0 of a trapezoid. So I divide each side by h, and I'm left with 2a over h equals b1 plus b2. Now notice I have nothing being multiplied to b1 and b2. Okay, that quantity, they're all by themselves, so now I can isolate my variable b1. I couldn't just subtract here because of these two multiplications. So now to solve for b1, I just simply subtract b2 from both sides, which is what I've done here, and I'm left with b1 equals 2a divided by h minus b over 2. Please be careful, the b2 is not over h, okay? Only 2a is because we divided that by a. So if you have any questions, comments, concerns, you can email me at nicholas.bennett@dc.gov, or you can type your comments below. Thanks, guys.